So basically we have different divisions at research, including automotive and process and different parts. I'm the division manager of plates, energy, and infrastructure products research. My group is the non-automotive side, especially focusing on the heavy gauge. So basically our plates division and also our energy and infrastructure products development and applications support. So what we do is we not only develop products, but we also implement solutions with customers so that they can use these products very effectively. So we have, first of all the regular tools, like metallography and things like that. Then we have, for example, a very advanced welding setup that are quite unique, specifically focused on having plates and other heavy gauge or to weld these materials. In addition to that, we have some very, very unique new acquisitions to our lab. For example, the roll bending machine. We have the fatigue and fracture testing at very low temperatures. And then we also have a drop weight tester. Basically, we need strong and tough steels. So now what we have here is really to measure, because we need a metric to go by. And the conventional Sharpie impact testers are really not enough to measure the toughness of the steels that we develop. So we go for a very high energy Sharpie tester. We have that up and running. And then to accurately measure the strength of the pipe that's produced by our customers, we also have the ring expansion tester. I'm not aware of any other American research lab that has a ring expansion tester. It's quite unique here. And this is what we take to our customers, and our customers are quite pleased that we have actually installed these new equipments. We are also involved in developing more puncture-resistant tank cars, tougher steels for line pipe. The other thing we are trying to do is the customer solution support, like we have been very successfully doing for automotive.
For steel industry, the automotive products are clearly the most demanding products that we make. And the requirements that are coming from our customers, both in terms of quality and in the in-use properties, has been what's driven our focus on R&D.
The hot strip mill, cold strip mill, and anneal simulator play an important role in our work. Primarily, they actually allow us to replicate a lot of the industrial settings that we find out in the actual plant. The other important factor is that the products that they create are also similar to what our ultimate product is going to be that we ship out to customers.
The car makers, one of the things that they are considering very strongly is redesigning their existing structures with thinner and higher strength steel. We are designing steels that are so strong and so easily ductile and formable. You put it in a furnace, you heat it up to temperature, and then you hot stamp it. And the advantage with that is that you can stamp really complicated parts that you couldn't before, and at the same time, you get very high strength. And that is very important for crash energy management and weight savings. The hot stamping lab is a place where we evaluate the performance of the material that we develop under industrial hot stamping conditions. Car companies also want us to test the products to see how the product will perform when actually the products are stamped. So the hole expansion test is one condition where a hole is punched in the sample and then you expand the hole. In the past, people used to stop the test based on their manual observation of if the material cracked or not. As you can imagine, depends on the person's eyes, depends on the reaction time. So what we did was we developed this method where the camera takes pictures continuously, and then we have written a software that helps us stop the test when the crack reaches a certain length. And so the tests are a lot more repeatable, and the customers have a lot more confidence in our data. That development of the camera-assisted hole expansion was done in this lab.
In a car, you may not realize that all the parts have to be joined together, and spot welding is one of the technology they are using. There might be 3,000 to 6,000 welds in a car. So there's welding all the time, and the quality of the welding are so important. So whenever we develop a new steel grade or develop a new coating, we have to make sure that our customers can use it safely. So we have to pass many other testing as well. Spot welding is one of the major qualifications we need to finish to make sure that our customer can weld them together and they can obtain very good mechanical properties, and the steel will be used in their car very safely.
So it's critically important for us to understand how our sheet products, when we make them, weld to each other or weld to some other kind of steel. And the way we do that is we have a lab where we do the spot welds and we also pull them apart and then see how they perform. Because what's important to car makers is that not just how well it joints, but also how well does the weld perform in a crash. And then this lab, what we do here is we test panels to find the force it takes to make a dent that is visible by you and I. It's really important for car makers to characterize that, to see how much force it takes to make a dent. We've done a ton of tests here in this lab and have been very successful actually in convincing customers to go with lighter and stronger steels for applications such as doors, fenders, hoods, things like that.
One might find this amazing because we are making thousands and thousands of tons of steel, and you see these large panels and large coils that we make. But in really able to understand how to make these steels that much stronger, we need to look at micro level. And for that, we need very high-end equipment. We have been able to bring those resources and those kinds of equipments to our laboratories.
Because of the unique recipes that we're using to obtain properties, it presents a challenge for the coatability. That is how we get the liquid metal to adhere to the strip. Now, this equipment that you see here allows us to reproduce all of the conditions in the mill that the strip would experience right here in the laboratory. So we can save time and money, so we don't have to run multiple coils through the industrial process. We can run smaller 5-inch by 9-inch panels, and we can study very carefully how the surface chemistry is evolving through a continuous galvanizing line. The X-ray photoelectron spectrometer, that is a very surface-sensitive piece of equipment. It measures atom layers at a time, and we can determine very carefully what the chemistry is. This is critical for designing practices that we would then use out in the coating line. The SEM is a scanning electron microscope, and this allows us to look in high resolution and high magnification to examine the surface of the material, to look at the coating morphology. We can look at the different phases of metallic coating that are present, and this helps us understand better the application of that coating. For example, if it goes off to a hot stamper, how it might behave. It allows us to troubleshoot coating problems and really see the minute details of that material.
I run the corrosion lab here at ArcelorMittal East Chicago. I get to destroy things. If everything just worked well and lasted throughout the test, it'd be no fun. But part of my job is to make things rust, so we can put them in aggressive environments, whether it be a salt spray, we can heat them up, we can put them in 100% humidity conditions. We have a couple other tests where we actually use ammonia and nitrates and chlorides, and it's just a way of accelerating corrosion much faster. It's not whether or not they rusted or not, it's which one didn't rust as much, or which one didn't peel the paint as much. Then we know which combination of paints or metallic coatings or materials work the best.
This is the kind of testing that's absolutely critical to make sure that our steels are utilized the right way, in the right component, and also the car companies have utmost confidence in our products and also in our services. And so it goes beyond just shipping the product.
All our activities keep us competitive, and developing new grades of steels are absolutely necessary. Many of the advanced high-strength steels that we find today weren't in the market 10 years ago, and so all this equipment is vital for our research.
At the end of the day, we'll all be played in the field of technology differentiation. And technology differentiation will be based on the ability of one company, one nation to outcreate another.
It brings a new challenge to the entire technical aspect of the work. And of course, technical challenges is something that kind of draws a set of talent and makes people kind of enjoy the work.
It's not created by machines. It's created by people through their ingenuity and through their creativity.
When we design and develop new products, we go much beyond meeting just the basic properties that the customers require. We want to make steel the material of choice. And the kind of testing, the kind of evaluation, the kind of analysis we do is critical to make sure that happens.